Bismillah ar-Rahman ar-Rahim. In this tutorial, we will learn how to use Xschem and Ngspice to run a circuit level simulation. So I will open my home directory. I will create a new directory here. Let's name it our first project. I will open this new directory. Inside this new directory, I will open a terminal. And inside this terminal, I will run Xschem. So Xschem window opens, as we see here. The default schematic name is untitled, so let's use save as to give it a name. And I will name it RC circuit because I will create an RC circuit now. So I'll click OK. Okay, so now we have RC circuit and the extension is .sch, which stands for schematic. So now I want to add my components from the tools menu. I can use insert symbol, or I can use, of course, the hotkeys here. So I will use insert symbol. The choose symbol window will open, as we see here. On the left, we can choose the library, and on the right, we can choose the components. So most of the basic components are in the devices library, which is built inside Xschem. So it is selected by default, as we can see here. You can search for the components by using this scroll, or you can use this search bar. So I will write, for example, res. I'm searching for resistor. So this is my resistor. I can see here the symbol. I will click OK, and I can now place my resistor. To change the orientation, I will use the hotkey Alt-R. So I will press Alt-R on the keyboard to change the orientation, as we see here. Okay, so now I have my resistance. I will repeat the same procedure to add the other components, tools, insert symbol. But this time I will choose the capacitor. So I will write cap. This is the capacitor here. I will leave the orientation as is. I'll just put it like this. Okay. Now I will use the hotkey Control I. This is the hotkey for insert symbol. And it also shows actually the recent components. I will search for ground to put the 0 voltage ground. I will put an instance here, and I can copy it as well. So to copy it, I will press C on the keyboard, and then I will move my mouse pointer and click in the new location where I want to place the copied symbol. So now we want to add a voltage source. I will click Control I again. I will search for V source. Okay, so this is my voltage source. Click OK. I will place my voltage source. Press Escape. So now I want to zoom fit my schematic. So on the keyboard, I will press F. Now I have a zoom fit. I want to add the wires. For the wires, you can use the hotkey W. So I will press W on the keyboard, but before pressing W, I will put the mouse pointer in the location where I want the wire to start. So I will press W and I will move the mouse pointer. And as you can see here, I have the wire moving. So when I click, the wire stops. So I will go here and then click, the wire stops. Put the mouse here, press W on the keyboard. I will have the wire again. I will click, the wire stops. Put the mouse here, click W, and so on. Now I have my circuit connected. So let's maximize this window. I can zoom in and zoom out using the mouse scroll, and I can select all using Control A, and to move I can press M, the hotkey M on the keyboard, and then move my mouse pointer. I can see the circuit moving here, so let's place it here and press F again to do zoom fit. So now I have my circuit ready, but I need to set the properties of each component. So to edit the properties, you select the component, you can right click and click here edit attributes. And the attributes are edited in the form of text. It is not a GUI, you need to write the text here. So the value, as we can see, is 1 picofarad. I will leave this as is, I will not change it. And instead of right clicking, I can also use the hotkey Q. So if I press Q on the keyboard, I will get the edit properties window. and we can see here the value is 1 kilo ohm. I will leave it as is. I will not change this, but what I need to change is the voltage source. The voltage source by default is a DC voltage source with a value of 3 volts. What I want to do is to create a pulse. I need to create a square wave. So to know the syntax of how to create a pulse, I will go to the Ngspice manual. So I have the Ngspice manual here. This is Ngspice manual. And I will search for pulse. And this is how to set the voltage and current sources. And this is how to set a pulse. These are the parameters that I need to put. So I will copy this. Okay, and as you can see here, V1 is the initial, V2 is the pulse, the delay, the rise time, the fall time, so on. So I will copy this, and I will go back to my schematic here. So I'll go back to my schematic, and here in the value, I will put double quotes, and I will put my pulse here. Of course, I need to replace this text with numbers. So assume I want to use a pulse from 0 to 1 volt. With a delay of 0.5 nanosecond, T-rise of 100 picosecond, T-fall 100 picosecond, the pulse width, let's set it to 1 nanosecond, for example, and the period, let's set it to 2 nanosecond, and I will leave the number of periods empty, blank. So these are my settings. I have a pulse with almost 50% duty cycle, period of 2 nanos. I will click OK, and you can see here the new settings I have for my voltage source. Before running the simulation, a good thing to do is to define the wire names. So I will add labels for the wires from the Tools menu. I can use here Insert Wire Label, or also I can use the hotkey. I will use Alt-R to change the orientation. So I'll place a label here. I will click on the label, press Q on the keyboard to show the properties, and I will edit the label here. I will write VIN, and by the way, Ngspice is not case sensitive. So actually VIN in capital letters and VIN in small letters are exactly the same. There is no case sensitivity here. So now I have a name for this wire. I will select the label, press C on the keyboard to do copy, and then move my mouse pointer and click here. And now click Q and change this to Vout. So now I have my complete circuit. I need to save it. I will use the save command here, or also I can use the hotkey, Control S. So now my schematic is saved. You can see here it is saved. And I'm ready to run my simulations. So how to run the simulations? Let's see here what we have. We can configure simulators and tools from the simulation menu. And by default, Ngspice is selected, as we can see here, so I don't need to do any changes. Before running the simulation, I need to define the simulation command. So I will press Ctrl I to insert symbol, but this time I will choose my symbol to be code, and in this code we can write the simulation command. It can be shown where the code will be shown in the schematic, or it can be code only to show up as a black box here. So I will use code shown, click OK, I'll place it here, and I will edit it, and here I want to write my simulation command. So let's put this in a new line. I will remove this blah blah blah, use the double quotes because I will write actually here multi-lines. I will run a transient simulation, so I will use the command .tran, and here I need to define the step and the stop time. So let's assume that my step would be 100 picosecond, and I want to run for 5 periods, so my period is 2 nanos, so I will define the stop time as 10 nanos. And I want to save all my waveforms, so I will use the .save command, and I will save everything. And again, you can review actually this stuff in the Ngspice manual as well. You can see how to write the transient simulation command and any other simulation command. So I'll click OK. So now I have my simulation defined. Let's move this here using the hotkey M. I will zoom fit again, and now I'm ready to run my simulations. So what I need to do is to click netlist. This creates the netlist. If you want to review the netlist, from the simulation menu, you can use edit netlist here, and this will show your netlist with components, the simulation command, everything is shown here as we can see. So I'll close this and I will click simulate. This will run the simulation as we can see here. And now I will use the plot command to plot the waveforms. So we'll use plot, in, out, and as we can see here, I have my square wave and I have my output, the blue line here, the RC circuit output. So this plotting interface is a bit primitive. We can plot the waveforms using different methods. So let's try another method. I will use a waveform viewer. I will close this. But to use the waveform viewer, I need to write the simulation results in a raw file. So let's go here to configure simulators and tools. And let's choose Ngspice Batch. Ngspice Batch also actually creates a raw file here that contains the results of the simulation. So I will choose accept and close. Let's save our netlist. Okay, I will netlist here and then I will simulate. So this is Ngspice in batch mode. I can see the simulation is completed, no errors. It tells you that the simulation output is saved in this raw file and any comments and warnings are in this output file. So this file contains the simulation data. To view the waveforms in this file, I can use the waves app here. So it opens up here. And then I can choose my waveforms. Drag and drop to a wave panel, as we can see here. So I will drag this. As you can see, this is the output. You can also drag this. This is the input. So I can plot my input and output using this interface. So there is another interface that is actually even better than this one, which I can use from the simulation menu here. I can choose add waveform graph. So this is a waveform graph. I'll place it here. I will click F to zoom fit, okay? And I will also add a waveform reload launcher. This will load the raw file into my waveform graph. You can actually edit this text, and I will edit it with the instructions. You need to press Ctrl and left click to load the simulation data. Okay. So I will save this, Control S, okay, list, simulate. So I have my simulation data here. I will press the Control key and then click. Now the simulation data is loaded and I have a plus sign as we can see here. I will double click and I will have here my waveforms. So let's select V in, select V out, add them here. You can change the colors, so I can change this to be a red color. Click OK, and I need to fit the plot. So I will go here to the x-axis, press F, so this will fit the x scale. I can go here to the y-axis, click, press F, so this will fit the y scale. So now I have my simulation data. The nice thing here is that you don't have to open another application to view the results. Everything is inside the schematic window. So let's assume I actually want to make my RC circuit faster. So I need a smaller time constant. So let's edit the capacitor here to be just 100 femtofarads. Click OK. Now my schematic is edited as we can see here. So I will Control S, save, and netlist, and then simulate. So I have a new simulation result, but it is not loaded yet. To load this simulation result, I will first unload, press Ctrl, left click, now it is unloaded. Press Ctrl, left click again, now the new simulation result is loaded.